top, see the flashes, this is a wastage of material. And again, the operator has to take a sharp knife and he has to remove that. And this is a, time consuming and cycle time may be increase. Again, you have to recycle this material. If this thing will happen, then it is not economical for the industry also. And the quality of the product is not acceptable. And hence, these countermeasures also use at the main part is that the root cause, parting line no good, low clamping force, and injection pressure too low. These are the main things generally happen. But many times, uh, by temperature, you have to also see the temperature here also, friend. Temperature play also very important role. If you increase the temperature, then definitely it will try to, the flash will be there by, and hence we have to refitting, use appropriate clamping force, injection pressure, and temperature. These are the main countermeasures. Now, mode release agent or mode release faults. See now here, there are marks are always observed on the articles. See, this is a marks, pin mark, or maybe the ejector pin mark. Why this pin mark observed? It is also as a drag or pull marks is also pull mark. Now, friend, why this happen? Is because the defects is a poor release. 1 minute. Improper ejection from the mold. There may be, that ejector pin damage the article, or maybe, that pull the article. This is generally caused due to the overfilling of the mold with the polymer made, or by insufficient, that draft or tapper in the mold. Friend, these things are always observed. What are the root cause behind that? Improper polishing. If you not polish your pin, then definitely this mark will be observed. Maybe there is a sharp pin, and the sharp pin always, that create the such a impression on the article. Unbalanced ejection. This also creates such a type of uh, pin mark on the article. Cooling type not enough. If you are also not giving cooling enough time, this mark will be observed. Suppose here is a cooling time, okay, but here is a not cooling time, okay. Then again, there will be mark on one side. Full mark, improper polishing, and draft tapper not enough, that we have already seen. Now, what are the countermeasures? Proper polishing, appropriate cooling time, and draft tapper should be, appropriate. Then and then you will get the a quality article. The design and for undercuts. See now here. See, this is going one side. This is also going one side. See now the article here. See now this is a cavity mode. Cavity mode at the top. This is a base mode. This is a ejector. See the article here. This is the article. Now this is the undercut here. There will be cavity move. See this cavity move to the top side, and this slider move to the right side. See here in this first case. Now see this in second case, what is happening? The cavity moves upward, but the angular pin push the part. This angular pin push the part out from the core side. See now here, and such a type of that design for the undercut also you some troubleshooting. Now short shots. That article is not filling the 100%. If you see here, the the article is not a 100% uh, filling. Why this happen? Article may be too thin, injection pressure not a proper to fill the article, or maybe there is air trap. These are the possible root causes for this short. There may be insufficient even material in the hopper. There are a number of causes are there, friend. Not a these three causes. Not only these three causes. There are a number of causes. Even you are not adjusted that limit switch, feedstock limit switch. You are not adjusted. That also create these problems. Short. Hence, by try and error method, once you set up the limit switch, then you will get the a proper article, 100% filled article. See now, it is not acceptable. See, this is also same thing here. Now, what are the countermeasures for this? Avoid design too thin. Increase the injection pressure and sub-insert. If you increase here sub-insert or injection pressure, definitely you can overcome this type of fault. Now, sink mark. See, sink mark, where the sink mark always observe where the thickness is higher. See now here. So, see the thickness, very high thickness. Okay. Now see this sink mark here at the rib, below the rib. Sink mark is there. And this is a very, that danger place frame. The article will break here only. The article will break here only. Now, the sink mark indentations on product surfaces, it is the most frequent defect in a molding. Why this occur? Because of the volume shrinkage during cooling. See now here, when it cool first very fast because of, see the volume here is a very high volume, and hence it get cooled first as compared to this and this portion. Now, why this happen? It takes time to cool a center portion of a thick product so that the skin may be collapsed to the create sink marks. Now, what is happening here, friend? If it cools here, equal cooling is not there. Why equal cooling is not there? Because of your equal thickness is not there. This portion will cool fast, this one. And see, it will take a time. But at that time, we are removing the article from the mold. Then at room temperature, here the chains present here, they get shrink more at the room temperature. And therefore, after removing the article, when you keep the article in the store, what will happen? This sink mark will be observed. It is after some time, after molding. Because of the uneven cooling, uneven thickness of the article. See now, it's a poor design here in this case. Therefore, sink mark will be, will be here only. It will observe here sink mark because of this type of design is there. The design is wrong here. Here, wrong design. Therefore, part design also play a very important role in troubleshooting. Therefore, how you improve this? See now here also. See the voids are present here in this case. See the voids may be a complete cylindrical type, or maybe a completely rod type. Now, how you improve this? See now here, improve design. If you want such an article, you improve the design. You can save the material also, and there will be no, sink mark. And the life will be higher as compared to this. Here also you can not saving the material. It will take a time. See the now uneven time. See the thicker. Therefore, it will take a more time. It will take a 25 seconds, but this it will take only 15 seconds. Therefore, see the 10 second increases here, and hence thickness also affect the cooling of the article. And hence you will observe the sigma mark on the article. Any question here? Hello? Hello, any question here, friend? Hello? Any question? Am I audible to you, friend? Hello? Am I audible?
Yes, sir.
Yeah, okay. Now, what are the root causes of the sink marks? Per design. It may be the root cause. See now here, the design is wrong. See, the design is wrong. Injection pressure not enough. This may be root cause. Coding pressure time not enough. This is also a root cause. Cooling time not enough. Hence, see now I told you, cooling time is not enough here. Because of, see the thickness. The article thickness goes on higher and lower. And hence, this will create the sink mark at the back side of the article. See now here also, sink marks. See, यहाँ पे sink marks, sink marks, sink marks, sink marks. See the sink mark here. See the sink mark. See, here is also sink marks. It is called as sink marks. See here. All sink marks are there. So, friend, sink marks on a cylindrical core without temperature was not controlled correctly. See, this is uneven temperature here. See the temperature here. And see the temperature here. See the here, uneven temperature. And due to that, this type of marks will be observed. The brain, cooling is very important. Temperature also play very important role here. Now, weld line. See the weld line here. In this case, it is a weld line. And this will, the defect in the article. See the gates are here from which the material will pass. Here, it will form the interface of a polymer. See now, interface here and here. This is interface of the polymer made flow from two different paths. See, यहाँ से material आता है, यहाँ से material आता है. Two different paths. And therefore, the weld line may be, formed here. And it is unacceptable in terms of the surface appearance or reduced physical strength. See, material will pass from here also, material pass here also. And here it is a formation of a weld line. What is the root cause? Part design. Part design is not proper. Therefore, gate is not proper way. You have to identify a suitable gate there. Therefore, countermeasures are you have to create the air vent there, sufficient air vent to the mold, ejector pin, then some insert you can add this here, then texturing. This is also possible in this case. Or increase the mold temperature. If you increase the mold temperature, so definitely it can be overcome by the this well line default in the article. Increase mold temperature. This is also a very simple way. Now I told you mold temperature play very important role. Yesterday, that day also I have shown you the mold temperature for various material. Complete one slide I have shown you. Now, friend, warpage or warping. Why this warpage observed in the articles? If you see here, friend, it completely see here a rectangle or maybe a square type of article is there, but see how it is get deformed. It is not that a straight wall thickness. This is the happen due to the shrinkage throughout the part. There are lot of shrinkage take place here, here, and that's why the article is deformed completely. Shows warpage at all corner, at all center. Therefore, why this happens? Due to the shrinkage, variation in the shrinkage. Shrinkages take place, but there's a lot of variation. Now, what type of shrinkage is there, friend? Shrinkage observed due to the orientation. Also, the shrinkage due to the area and differential cooling. If you increase the differential cooling, the shrinkage is the main factor for that. The friend, these three things have effects or maybe having effect on the shrinkage: orientation, area shrinkage, and differential cooling. These three things are maybe male culprit for this warping. And you have seen the many jumbo article also, or jumbo crate, jumbo tray. There are a lot of variation in the thickness, or maybe the side is get bulky at the center. If you see, observe here in this case here, if you see here, friend, here also the material orientation direction, this orientation here. This is the original article. See, this is the original article here. But after shrinking, it become like this. After shrinking. Lot of shrinkage is there. Maybe here 5 millimeter or maybe either 20 millimeter. Why this happen? Why such a shrinkage will be observed? Because of the orientation. What is the orientation? Can anybody tell me? Hello? What is mean by orientation? Orientation nothing but is the alignment of the molecule in the direction of force. What is the orientation? It is the alignment of the molecule in the direction of force. And therefore, what is the shrinkage? Shrinkage is nothing but is the relaxation process of oriented molecule. Shrinkage is nothing but it is the relaxation of oriented molecule. And that's why, see now here, the more and more orientation take place here in this case. This is the original size. See, after shrinkage, it become like this. This shrinkage due to the orientation. This orientation due to this. See now, इतना होना चाहिए. Maybe 8 centimeter, but it's showing only 7 centimeter width. Now see here, Shrinkage due to the area shrinkage. This is area shrinkage. Now see, the article is like this. See now, article is now become the dotted line. Therefore, there is overall shrinkage. दोनों साइड से श्रिंकेज, एरिया श्रिंकेज, एक साइड से श्रिंकेज, ओरिएंटेशन श्रिंकेज. And the third possibility is that differential cooling also affect the shrinkage, uneven cooling. And that's why this warpage will take place. Warpage will take place due to the shrinkage in the article. Have you got, friend? Hello. Any question here? Any question here, friend?
No, sir.
Okay, we will go ahead now. See, the root causes, I told you, cooling channel, cooling time not enough, part design is not proper, imbalance ejection. And that's why the warpage will take place. Now the silver marks or silver streaks, see now here, some silver streaks are there on the article. See the black article. See the white lines are there. That is called as a silver marks or silver streaks. Why this? Observe, because of the moisture present in the material. And this moisture creates the gases in the melt. Therefore, and that's why we are preheating the material, or maybe some air present in the material, it shall be removed first. And therefore, you should use a proper drying temperature for that. Drying temperature may be very high, maybe 100 degrees, but time is less. It will not work. If you increase the temperature, you also increase somewhat few seconds. Time also. Therefore, pre-drying and while pre-drying the material, you have to take in mind that the temperature of the oven and the time in the oven, that two things play very important role. If the time is less, such a thing will happen. Therefore, temperature may be 90 degrees, you have to keep that material maybe 2 hours, maybe 1.5 hours, by taking a consideration of the stability of the material and which are the ingredients present in the material. Hence, timing or duration of heating and temperature are very important factor for preheating the polymers before putting it into the mold. Now, what are the actually root causes? Drying temperature and air trap. What are the measures here for this? Measures are there. You have to remove the moisture which is present in the granules. Therefore, oven is there, hopper dryer is there, the dehumidifier is there. There are many things you can add this here for the remove the moisture. 1 mark. See this article here. The black at the corner, both corner. Why this happen? Maybe while filling the article, the ear may be trapped here and here. Due to the ear trapped inside the mold at the corner, the article will start to burn at that place only. And hence, the article become dark here, friend. Material become a degrading in this case. Delamination. See, the delamination is like this. The skin will be out here. Delamination is nothing but it is a layering. Here, this skin of this article can be peeled out or peeled up layer by a layer. One second, third, fourth, like that. What are the root cause? Incompatible material blended together. Therefore, that means whatever two or three you use the material, that is, they are not compatible with each other. And hence, after molding, they get peel out or maybe delamination. Therefore, compatibility of polymer is very important here in this case. Too much mold release agent, being used during the molding process. And it also create the delamination. Low melt temperature in the cavity. Rain is low melt temperature in the cavity. It also create the delamination. Excessive moisture. See here, delamination. See the delamination. See the delamination. These are the all article. The skin is get peel out. The sharp corner at the gate and runner. This also affect the create the delamination of the article. Dimensional variation. See now here. इतना dimension था, इतना article था बड़ा. Now it get reduced here. Maybe 10% or maybe 8%. Why this happen? This dimension variation is defect by the molded part dimension varying from the both or maybe batch to batch or to form the short to short, while the machine setting remain the same. Why this happen? Unstable machine control, a narrow molding window, improper molding conditions, a broken check ring within the injection unit. These are the these are the root causes, and that's why see here this dimension get change. Unstable material properties. Now discoloration. Now you are using only red color, you are getting the faint red color. You are using a yellow color, but you are not getting a complete yellow color. There may be some blackish color. Why this happen? This is what is a discoloration. This molded part color change from the original material. This is what is the discoloration. This defects caused either by degradation or by contamination. Now, degradation means you are using a higher heat, and contamination means whatever material you are using that I initially get contaminated. Now, the material stays in the barrel too long, and that's why material start to burn in the barrel only. And burn means it changes color. There's always the effect of heat on the color. If you see, if you go with a good new shirt in a sunlight for walking purpose, what will happen? After a few days, the shade become a faint because of the effect of the sunlight. Same thing happening here. You are keeping the material a long time in the barrel. That means residential time is proportional to the color change or discoloration. And here's, if you observe, the barrel temperature is too high, causing the color to change. Contamination was caused by the reground material, different material, and foreign material. Fish eyes. See now here, these are called as the fish eye. This is unmelted material. It's not completely made. And that's why this type of fish eye will be observed. So, friend, you have to observe this fish eyes fault. This is due to the melt stream, unmelted material, which we have injecting or forcing into the cavity. What are the root cause? Low barrier temperature. If the barrier temperature is too low to melt the material completely, the unmelted pellets will merge with the melt streams, marrying the surfaces of the part. Second is too much regrind. If you use a too much regrind, therefore maybe 30, generally we are putting the only 20% regrind material. But there are some small scale industries, they are using the higher quantity of regrind. And here's the shape and size of regrind is irregular shape compared with the original material, which can trap more air and causes the material to blend unevenly. Then material contamination. If a high melt temperature material is blended into the original material, the blended material may stay in a pellet form and causes a fissure during the molding process. This is also a root cause for the fissures. Then low screw rotation speed and back pressure. If the screw rotation speed and the back pressure setting are too low, there might not enough a frictional heat to melt the material. And the material is not homogeneous before the injection. And this also create the fish eyes on the article. See, the fish eyes are like this. Any question here, friend? Hello? Any question? Now, flow marks. This is also one defect in the article, injection molded article. A flow mark is a surface defects in which circular ripping on a wavelength appears near the gate. See now, this is the circular ripples. It also observe at the gate only. It is a gate. यहाँ से मटेरियल जाता है. But friend, what are the root cause of flow marks? Flow marks are caused by cold material near the gate or lack of compensated material during the packing stage. The problem usually can be attributed to the low melt temperature, low mold temperature, low injection speed, low injection pressure, small runner, stream, and gate. These are the main causes of the flow marks. Low melt temperature means definitely you are getting the weld line there. Low mold temperature, it also creates the same problem. Therefore, mold and melt temperature should be optimum. Even injection speed and injection pressure should be optimum. Now, these are the factors which can overcome this flow marks frame. We have to alert for them. Now, jetting. Jetting is a generally problem observed in many cases. Now, what is meant by jetting? When the polymer mate is pushed at the high velocity through the restrictive areas, such as a nozzle, runners, or gate, into open, thicker areas without forming contact with the mold wall. And this creates the jetting. The buccal snake-like jetting stream causes contact point from the between the poles of the mate in the jet and creating a small scale welds. You see here. See the jetting here. This is called as jetting. And if this present, what will happen? It weakness the article. Surface will be, it is get blemishes. And therefore there may be internal defects. And in contrast, this normal filling pattern in which the mate advances a progressive pattern from the gate to the extremities of the cavity. See, this is normal filling pattern like this. And see, this is jetting. How you overcome this? By using the overlap gate and submarine gate. This is submarine gate. Overlap gates. See the overlap gate here. The gate is given like this. And see here, friend, how the material gets spread inside the mold. And hence, this gate, we should know the overlap gate, tap gate, or maybe fan gate. See, this is a tap gate. And this is a fan gate. Hence, friend, the material gets spread evenly in the article. We can overcome these jetting problems. Now, the next part is hesitation. What is meant by hesitation? See now here the part thickness is not correct. See here is maybe 6 mm. There may be 2 mm. And see the gate. What is the gate? Gate is here. This is the wrong design. When you flow the material will start flowing in this bigger area, thicker area than this. And hence, we want a uniform flow in the cavity. But see now here, a thin, only 3 mm. See, this is a 7 mm. And this is the main problem. It will create the hesitation. Here, the material start to stagnate first. It is because of the thin section. And therefore, where is the thickness is a maximum, or maybe part thickness, or moving the gate location. And therefore, friend, when polymer melt is injected into the cavity of a variable thickness, it tend to fill the thick and less resistance area. This one, it will first fill this. First, it will fill this. What will happen due to that? The polymer will stagnate here at thin section until the rest of the part is filled and stagnant polymer may start moving again. See now here, it is again start to move from this place. And therefore, if the duration of the agitation is significant, polymer will solidify prematurely at the stagnant point here, either. It will get a freeze here first. And when the solidified made from is pushed to the part surface, a surface defect such as a agitation mark occur. And therefore, here the agitation marks will be occur. Because the see now, the gate is here. It is not a even. See now, it is a poor design. It is a improved design. See now here. Here is a gate. पहले यहाँ पे गेट था. See, this is a gate, not here. This is a gate here. And the material will get injected here. The material will get spread here uniformly. But see now here, it get afterward filled. Now see, this is the right approach. When you force the material inside this gate, what will happen? First, it will try to fill up this area and then this area. And hence, you will get 100% article here. You will get here a 90% article in this case. It's a poor design. This is the correct design. Now, what are the main common faults in the injection molding process? Flashing, the causes injection pressure too high, clamping force too low, mold fitting not good. That's why the flash is there. We have seen warping or warpage, non-uniform cooling rate, and that's why warp is always observed in the articles. Bubble may be due to the higher moisture in the material. Short mode. There may be air trap or maybe injection pressure not enough. And that's why you have to remove the air trap, or maybe you have to provide the vent and apply the maximum pressure, injection pressure. And therefore, you can overcome this short mode defect. Now, sink marks. You have seen the sink marks. Why this happen? Injection pressure too low. And that's why this thing will happen. And non-uniform cooling. This is also one type of fault. Cooling rate. It will create the sink marks. Ejector pin mark. Ejector pin mark. Cooling time too short. Therefore, the material is heated and you are getting a attack of a pin. And therefore, there will be pin mark. Second is that the ejection force too high. When you remove the article, the force you have to use the optimum, not higher. Many times, ejector will give a very excellent shock on the article, like an impact. And hence, it will create the ejector mark or pin mark on the article. See now, here is a material sinking. See now here. These ovoids here. Zinc and ovoids. One minute. There were frames. See,
Hello.
hello. Yes, yes. Hello.
No, no. Please carry on.
Ha, ha, ha. See, these are the different modes. They are short, short, short. We are, having some videos. I'm just showing the with article. Afraid it is due to the microprocessors available in the market. And now, if you see you will buy the machine with the all machines having the microprocessor machines, you will get the previous data also immediate there. You have to change the parameters as per the old, that parameters. And then after that, the slow you have to change, slight you have to change the some parameters which will giving you trouble. Therefore, you can overcome this the many that troubleshoot or maybe many defects immediately by following the last time parameter. But you have to check up the grade also. The grade should be same because material having a different type of melt flow index. Even you have to check up the maintenance of the machine barrel, the temperature. It is maybe there may be the heater is not working properly. There may be cooling is not working properly. You have to observe this and you have to be caution. You have to tell the operator. You have to check up that the water flow valve. Water should not stop inside the mold, and you have to check up the mold temperature. Plus, you have to do the maintenance of the machine. And by going through all these things, correction, you can definitely overcome all type of troubleshooting in the molding frame. It's at the weld lines. See, shear frame, the mold lines are very problematic than the weld lines. Now you have to that overcome this fault. Hello, hello, hello.
Yes, sir.
Yeah, something wrong with the system. Uh, we was you know 1 minute. Separate. Jetting is very important, right? Many times while yeah. Okay. Hello. Kopatla. Kope. वरती. थंडे गरम पाणी आहे, पाणी. Friend, these are the only the possible causes and the solution for the flow marks, right? If you see, we have already seen this, that many of these defects. If you see the warpage also, I told you warpage done by the three ways. It may be shrinkage, it may be due to the orientation, it may be due to the area-wise orientation, and maybe differential cooling. These are the main causes of the warpage. Right. We have also seen this. Right. Now, this is the flow lines in the article. Then we have also seen these bovides in the articles. Then weld lines also we have seen why these weld lines occur in the article and how to increase the mold temperature to prevent these weld lines. Also, weld lines are the poor, that problematic, right? That we have also seen. Then by raising the injection speed and the pressure, it is also we can overcome this. Then redesign and the mold, right? To eliminate the partitions and otherwise switch to the material with a lower melting temperature or viscosity. This is also a possibility, friend, but we cannot switch on the switch the material because we want that same material for the article. Now, jetting, we have also seen the jetting in the article. This is a very good example of a jetting of the article. Then, the short, we have also seen the short. Why because of there are number of causes, and therefore we have to see the remedies also for that. And we have also seen the remedies, how to overcome this short, even burn marks. Now, we will take a 2-minute break here and we will start here reaction injection molding process, friend. This is a very good process and I have some slides. I will show you how this happened. I will take a 2-minute break and then I will come back again. Okay? Hello?
Okay, sir.
Yeah. Am I audible to you? Hello? Hello?
Yes, sir.
Yeah. We start now the new topic, that is the reaction injection molding. That is also a sub part of the injection molding machine, right? Now, reaction injection molding is the process by which we are converting a article. We are creating the article without, melting the polymer here, friend. Therefore, the monomer to article, this is the miracle of this process, friend. There is a no, there is a, that if we, generally what we are doing here, friend, we are manufacturing the polymer, we are doing the compounding of the polymer, we are make the granulation of that polymer by pelletizing process, and then after that granule, we are, that uh, used for the secondary process, that is for injection molding or maybe something compression or transfer molding. Now, here it is not like that. Here we are creating the final molding from the monomer. Therefore, the steps in between monomer to final product we are removing here, friend, and it is a very excellent process and generally used for polyurethane. And there are some polymers we are using this type of a polymerization, friend. This is a very unique process. People are using this on large scale, and it is a very economical process because here the energy required very less. It is not required like a injection molding machine, right? Power is less, temperature is less, and you are getting a good article, excellent article, bigger article, right? And let me know the start with this, reaction injection molding. If you see now here, friend, uh, uh, it is also called as a reinforced reaction injection molding. Now, friend, reaction injection molding and a reinforced reaction injection molding. Any difference? Can you tell me now here? Reinforcement, you are adding a reinforcement in the reaction injection molding. Therefore, one is simple reaction injection molding, and other is by adding reinforcement or fiber in the reaction injection molding, and therefore it is called as a reinforced reaction injection molding process. Have you got this, friend? The difference between RIM and RRIM. We are adding a reinforcement. That means we are adding a fibers in RRIM. Now, in reaction injection molding, two type of monomer are mixed together. Two type of monomer. They are mixed together before being injected into the mold, where they polymerize to form the plastic component. In reinforced reaction injection molding, reinforcing agent, I told you the filler, are added to the monomer mixer, and then injected into the mold where they polymerize to form the plastic component. These are the main two different, that process used to manufacture the big and huge articles. Now, there are two monomers. Both are in liquid form. Now, for example, polyol and isocyanates. These are the two liquid polymers. You have to meet these two polymer in a separate tank, small tank. And then you have to inject that, you have to mix that in that tank or maybe head, injection head. and then you have to inject that material into the specific mold. Very simple process. You have to passing the liquid inside the mold. In that mold, they get polymerized and you will get a direct article, immediate article. So this is a unique process, friend. Now, how to design this? See the project of this review the CAD operation. Design for the manufacturing is also very important in this case, friend. Now, reaction injection molding design, custom part manufacturing. Now, these are the parts can be manufactured by this process. Now, bezels. Bezels means frames, right? Bezels means frames. Maybe wash frames, any big frames you can manufacture by reaction injection molding process. Then covers. Covers also you can manufacture by the reaction injection molding process. Handles. You can manufacture this by the injection reaction molding process. Multiple part complete plastics enclosures and the internal components of the any machine can be made by this process. Now, what are the advantages of this reaction injection molding process? Large parts. The properties of the liquid polyurethane component enable them to fill the mold for very large parts. So, friend, here, if you see, you are polymerizing two monomer. That is what? Polyol and the isocyanates. Polyol and the isocyanates. By mixing these two monomers, you are getting a polyurethane. That means two component, isocyanate and polyols. By mixing together, you are getting a polyurethane by polymerizing. And then, if you are putting in the article, that mode, then you will get the article. Very simple. Therefore, large part you can manufacture by using this, the process frame. Very large article. Now, encapsulation of inserts. Am I audible to you? Hello? Am I audible to you?
Yes, sir. Yes, sir.
Yeah. Encapsulation of the inserts. If you want to, that manufacture, that a insert added the components, then you can use this process frame. Insert maybe any types. It can be placed into the mold prior to injection of the reaction injection molding material. This reaction injection molding materials can also encapsulate many inserts during the molding. Even you can add multiple inserts in the molding because there are two monomer, direct monomer converted into a article. There's no, the polymerization takes place in the mold, Fred. You are not manufacturing the granule here. This is the unique process. You are converting the article by monomer. Generally, you are using the plastics to make an article. But here, you are using the direct monomer. You know that from the monomer, we are getting a plastics. Then melting plastic, you are getting an article. But here in this case, what we are doing? Direct monomer to article. This is the, a very unique process. Now, thick and thick walls. It is possible in this case, friend. The reaction injection molding process offers the more flexibility to design the parts with a significant wall thickness variation. You can see we have suffering there in a compression molding, transfer molding, even injection molding also. The wall thickness create the problems. and the article is not filling properly. Once the article became filling properly, but it is not dimensionally stable because of there are many fault, maybe warpage, maybe sinking marks, maybe flow marks because of the wrong design of the article or the product. Now, due to wrong design of product, therefore wrong design of mold, and this will, observe in the while molding, you are getting the faulty article because of a complex or thin article or thick article, the variation. If the same article having a variation, then it is very difficult to the process print. And hence, this can be overcome by this process. You can manufacture variation in a thick, thin articles. Now, class A surface. The surface finish of the part molded with this reaction molding process allow manufacturers to produce a class A painted parts. It is a, that the texture of the surface is a very good. We can easily paint that structure frame. This is also one benefit of this process. The low cost tooling operation. I told you already. Low power, low temperature, not very high pressure, very low pressure, very low temperature. This is the main advantage of this process frame. This is economical, process frame. The low injection pressure of the reaction chamber process allow for tooling to be manufactured quicker, fast, and at lower cost than tools used in traditional injection molding or a structural foam. Therefore, if you see, friend, this is a lower cost process, and hence it is accepted by the world. Excellent process. Now, if you see, what are the raw material? What are the monomer here, friend? I told you the monomer are in a liquid form. Polyol. CH2, HO, CS2, CS2, OH. Maybe ethylene glycol. Isocyanates. This is the second monomer. This is the first monomer, this is the second monomer, which are stored in a storage tank that are eventually dispensed by the high pressure industrial pumps. You have to stir that. While you want to use these monomers, you have to stir that initially. Stirring करना पड़ता है उसका. Then the polymers are recirculated from the storage tank to the multi-stream mix head and back to the storage bank tank in a continuous loop. Now, friend, see here, that's a very unique process. There are two tanks. One polyol tank, another is the isocyanate tank. They have a separate pump that is for the dispenser. It's called dispenser pumps. That is high pressure pumps. That polymers are get recirculated here. Now, the reaction injection molding process utilize the low viscosity liquid. I told you, like a watery flow. This polymer expand and thicken through a variety of chemical reactions. After the polymer have been injected into the heated mold, they eventually hardens. Through the reaction injection molding design process, raw materials and the molding techniques can be selected. Therefore, here you have to observe weight, strength, density, hardness. These are the main characteristics of the process. The result is a polyurethane part with a much lighter weight and more intricate designs than those created by the ordinary injection molding process. Therefore, friend, here two advantages: low molecular weight or lighter articles with a huge volume. Secondly, intricate design. That means thick, thin, insert can be possible, friend. Intricate means complex article can be possible by this process. You can manufacture thin, thick variation. You can manufacture a thin insert variation. You can manufacture thick insert variation. There is any multiple choice. You can easily manufacture by using the reaction injection molding process. And hence, it is a low temperature and low pressure. I told you, low temperature and low pressure process as compared to the injection molding process, compressor molding process, transfer, any process. If you take any plastic processing process, this is the process which have a lowest pressure and lowest temperature, friend. And therefore used to mold many types of plastic parts. That part may be medical, that part may be used for the industrial purpose, that part may be used for the automobile purpose. Such a specialty, articles we can manufacture by this reaction injection molding process. And number of varieties are there, a very quick process. Therefore, whatever you are getting the article, it is a very strong. I told you lightweight, large article, and the article may be printed easily. You can use the rigid material to process this, the original article or material, the product. If you see the flammability, you will get a right UL94V for rating the flammability. The reaction injection molding material utilized by the design octavens in a two-component system, that is the polyol and isocyanates liquid, that are mixed at the high pressure and then bitter into the closed to loop of the low pressure. The material then expand to fill the article or to fill the mold, and then is ejected about 5 minutes. See now here, the reaction injection molding process. See the arrangement of the machine. See now, this is the one tank, small tank. This is another tank. It contains isocyanates. It contains a polyol. Two monomer, both are monomer present in the liquid form. See now here, these both are mixed. It is here mixing heads. Mixing head. We are mixing here. See now, this is a tool. It may be mold. You can see it's a mold one, friend. It's a cavity mold. See, this is the isocyanate here. Yeah, it is a polyol. Now, what is this? This is a high circulating pump, high pressurized pump. Before passing into this line, in a mixing head, this is a mixing head. यहाँ पे वो mix हो जाते हैं. Before that, you see here, they're coming together here, but they are not mixed here. They get circulated here. Very high circulation pump are there. And whatever the quantity you want, that can pump into this mixing head, यहाँ पे, both isocyanates and polyol. There may be, suppose, 100 ml, 100 ml this and 100 ml this. That can be measured in this by pump, and it will get, injected into this mixing head, where both isocyanates and polyol get mixed within a fraction of second. And then that mixer get injected into this mold. This is a mold here, friend. Now, after this, within a 5 minutes, you will get the article, friend. Very fast. Now, we'll go the second, slide. See now here. You can manufacture flexible foam or rigid foam also. See, now we are using for this our bed purpose. They can manufacture by the reaction injection molding process only, friend. See here, a flexible foam. Flexible foam, structural foam. You can manufacture by this process. The solid elastomeric rim, reaction injection molding process. Solid rim is possible by using this process. Then fiber reinforced that we have seen RRIM, reinforced reaction injection molding process. And this is a article we can manufacture both by rigid also and flexible also. Then composite, structural, we can manufacture by this reaction injection molding process. Now, what are the parameters in this process frame? I told you this process is a cheaper one, low pressure, low temperature, many advantage, large article. You can make a foam also by this using this process, solid foam, elastomeric structure of the polymers. We can, multiple things are there, friend. And now, if you see, the liquids require less pressure, maybe 100 psi, and lower temperature, 90 degree, than typical ingredients. They can be injected into the cost-efficient aluminum mold. See the mold we have seen just now. That is a maybe aluminum mold. Very cheaper one. Aluminum is cheaper. Not require very high steel or any other material. Therefore, our tooling cost is lower. The mold is heated up to 190 degrees Celsius. And hence, the exothermic reaction quickly brings the material into -3 to 5 and the prompt cures the part inside the mold immediately. Because the heat is developed there inside automatically because of the exothermic reaction. Now, the curing time vary from less than 1 minute to several minutes. See the curing time depends upon the thickness of the article. Depends upon what type of polyol you use. Depends upon the concentration of both monomers. They will depend upon also the part size, geometry, and the wall thickness of the article. There's the curing always affects by the structure of the article. Therefore, polymers reaction injection molding process can be chosen to produce solid, elastomeric, rigid foams, which we are using for these foams for many purposes. For pillows, for bed, for that hospital beds. They have plain flexible foams finished polyurethane parts. Now, see, this is the main process frame. You will get a more now clear idea here now. How you write down this process frame and how you understand this process, that is very important. I told you, this is the isocyanates tank. That is a polyol tanks. Two liquid form. Both are monomer. ये एक monomer है और the second monomer. Now, if you see here, is a heat exchanger. This is heat exchanger. Both are heat exchanger here. And this heat exchanger used afterwards. Now, how you start this process, friend? Here, see here. This is a isocyanate tank, polyol tank. See now here, from the here at the bottom, the material will flow from this, not from this. The material will from always at the bottom. Here also the material will flow, not here. It will flow from this process here. It will go at the bottom first. Now, when you start the machine, what will happen? The isocyanates will enter here. What is this? This is a metering pistons and a recirculation pump. Therefore, here the isocyanate get that stir here fast, and how much quantity you have to push. Maybe 100 ml, 200 ml. It will care of this pump. Only this pump. Only for isocyanate. Same thing here for polyol. What maybe 100 ml, 200 ml, what is the shot you want, you can easily pass here only, and it will meter here. Meter means it will measure only the 100 ml. Here is also 100 ml, it is also 100 ml. But it's a recirculation here. Due to hydraulic drive, it will get stir immediately there. Now afterwards, see here, the mode is here. Here is the mode, upper part, lower part, the cavity core. Now from this, the polyol will bring here. This is a mixing head here. See here, this is a mixing head. Therefore, this isocyanate and this polyol will enter here in a mixing head. After pump, this pump will inject the 100 ml here, and this pump will inject the 100 here isocyanate, polyol here. Therefore, here is a mixture of polyol and isocyanates here in this mixing head. Now, here the material get completely mixed, two monomer completely mixed here, friend. Immediate mixing. And afterward, after mixing, injection take place. Injection take place. This is the land area. This is the after mixer here, the material coming here. This is the dam gate they have used here. These are the vents provided. It is the exothermic reaction. Lot of heat is developed there. And this is a cavity, and this is a core. Cavity, a female mode, it is a male mode. Now, what is happening? Here, whatever the excess, suppose there may be 110 isocyanate, there may be 120 polyol. So what about? We want only 100. We want 100 this isocyanate, we want 100 this polyol. But here is a 10 is the excess, here is a 20 is the excess. Again, this 10 will be again going back. Return line. This is the return line. This is also a return line for the polyol. This is a return line for these isocyanates. Now, they are not going here immediate direct, because again there will be heat exchanger here, heat exchanger. Because they are get heated here because of this pump, and this pump, recirculation pump is there. They get heated here, and they are also here coming here in the mixing head, and they are get excess here, friend. Then they again retain here, but the temperature is very high as compared to this. Here's the lower temperature, original monomer. Now, due to this recirculation and due to this mixing head, temperature increases. We don't want to again return into here because they have a temperature high, here temperature low, and therefore here heat exchanger are used. What is the role of heat exchanger? To remove the excess heat due to this mixing head and the pump, which is created. maybe excess. This excess heat can be removed here in heat exchanger, and again it will get pour here in the polyol tank. Only one polyol will go to the polyol tank, and the isocyanate will go through this heat exchanger, and that way again it will fall into this isocyanate tank. And therefore, see this process, friend. Very quick process, immediate process, and whatever the 10 ml, 10 or maybe 100 ml, it will get mixed here immediately, and it will injected into the mold. And you can create the huge article, big article. Immediately the reaction take place. The article will form immediate frame there. Therefore, here we are not using the granules. Here we are using the monomer in the form of liquid form, right? And from the liquid monomer, we are getting the article, solid article, solid article, not liquid article, solid article. This is a low pressure process. See, the pressure is very less. I told you the parameter also. See, this is also the another diagram. Same thing. देखो. But see, the isocyanates, polyol tank. See, this is the pump. कितना पंप लिया देखो, कितना पंप लिया इधर में भी 50 ml, 50 ml this. Now, after get, that is a pump here. Then again it will get passed into, right? Suppose ये थोड़ा ज्यादा आ रहा है तो 20 again it will go return line इधर जाएगा. Again it will get here, but how it is going here through the heat exchanger? I told you we have to cool that. Now, how the article made up now? See, this is a mold here, and this is the upper core, and this is a cavity. Then this inner core, आप यहाँ पे ऐसा भी डाल सकते हैं, inner core and the outer skin, like this outer skin. You can create the article this way also, friend. See, outer skin and the inner denser core. It is possible in this case. The same diagram, nothing, no change at all. I told you, this is the tank 1, tank 2. This is pump here, which will meter material here, it will meter here. This is a cylinder, it will get press here, it will get press here, and it will go here in the mixing head. Excess material again go return back. This is excess, see excess going now back through the heat exchanger. Maximum heat get absorbed, and the temperature of this and this coming, it should be matched. And here the material get injected here, excess will go out, and whatever the material required that injected into the mold, and within 5 minutes the reaction will take place and you will get the article. Now see the design. We have to see the design of this reaction injection molding process article. Similar to injection molded component, although the larger surface area in excess of 2 meters square and thinner section can be produced. See now here, 2 meter square, you can produce the article, thinner article, very thin. The blind hole and extreme variation in wall thickness should be avoided whenever possible. Now, several components can be combined in one large die. See, you can manufacture the multiple article, multiple variation in a simple die. Then, part shrinkage occur in the mold. The amount depending on the material. Example, 1% for nylon. And allowances must be made for this in a die design. Therefore, while designing the nylon die, you have to consider this 1%. Excess rako, 1% excess, both dimension. Now, the third one is good surface finish can be obtained. If you see this finish of this, it's very good of the article. I told you, easily painted. The component maybe 45 kg are commonly being produced. See the huge article, 45 kg article you can produce. Component can be colored, that I told you, by the pigment, any color. And see the automobile parts or many parts you can manufacture by these, such as the materials, polyurethane, epoxy, and polyester and nylon. The most common reinforcement material is the hammer made glass, flaked glass, chopped glass, mica, polystyrene, and fiber optic nylons. Carbon, polypropylene are currently under the investigation. Now the material properties. This is a what RRA
Sir, one
reaction.
doubt.
Ha,
You
ha,
talk
ha.
about material. What about DCPD? Have you mentioned there material DCPD technology?
Which one? DP?
DCPD.
No, 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 no.
That is also a reaction injection molding, right?
Yes, yes. No, this is the reaction injection molding. This is the reaction injection molding. We are
Right.
we are converting a liquid polymer into the direct article. Okay. This is the another process frame. Here we are
So
using the
okay. In DCPD, it's a liquid. We are converting liquid form.
yes, yes.
Okay.
See now here we can add the glass content 30%. Right. You can add here glass also here in urethane, in nylon, in
Sir,
epoxy.
when sorry to interrupt you. When we are going to cover DCPD next class or this class only?
Which one? We can
DCPD
add.
technology.
Yes, we can add here also.
Okay. Yeah, maybe tomorrow, maybe today or tomorrow. Please cover it also. Okay,
Yes.
sir. Thank you.
Yes, yes. Now, friend, see, to illuminate the secondary painting, UV stable pigments can be added to the monomer. I told you any type of color is possible in this case, and you can manufacture the article by using the reaction injection molding or a reinforcer reaction injection molding process. And I told you many bumpers, body, automobile body parts, steering wheels, automotive industrial parts you can manufacture by this process. Large part, huge part, maybe 45 kg in a one shot. I told you these are the typical mold temperature, injection pressure, and a monomer. See here, temperature require very less temperature. See the pressure is very less, friend, as compared to the injection molding, compression molding, transfer molding. This process is the economical process, and people are using this process in the market, right? And they are, but it is a you have to take too much care, right? There are people don't know about this process frame because generally you have to isocyanate and polyol. You have to take too much care of that material, and there should be a precise everything. You have to the skill. You have to adapt the skill, and then you have to select this process, because nowadays all the EV car that is now going to come in the market on a huge scale, and for that purpose you should consider about this reaction industrial molding a process for to manufacture such a big type of articles, right? Now, Fred, there are some, I told you all these things, clamping force, very less, low injection pressure, cycle time is also, I have told you about this. No, this is, that's, see here, the clamping force, I told you the material with very low can be, see, 0.4 megapascal, very less. Low injection, that, and low clamping force required because of, see, because of the low viscosity here, friend. Because you have seen polyol and isocyanate, they are in liquid form, right? And the mold, maybe I told you, aluminum mold you can use to manufacture this zinc alloy mold. Even plastic epoxy mold also you can use for to manufacture the mold of this material, cycle time, right? And it depends upon the size and shape of the article, right? Your smaller part, you can manufacture. Large part, you can manufacture. देखो, maybe half kg material, half kg is better than the injection molding for the 5 kg part. A 1 minute part to part demold time is typical. So friend, you can within a short period of time you can manufacture the article. Now it's about Teflon and silicon wax mold release agent was necessary before each cycle. See here we are using, because if you want to manufacture the articles, there should be you have to use the silicon spray or maybe PTFE spray. Somebody asking me, sir, it is get stuck because you use this two spray, Teflon spray or silicon spray for this. For to remove the article easily, it will remove the article, and hence your productivity and your surface will be very good for this. Now you can also impregnate the articles. यहाँ पे you see mixing can be possible. Now I have told you the economical process and also the parameter we have seen. Injection, clamping force very less, injection very less, pressure is very less. You can manufacture any type of density, right? There are a lot of variation are there, and robotic is possible in this case. Now this is again the same diagram. Nothing is no change at all. Okay, we have seen this frame. Now today we will finish this here, and now we will start. Our injection molding process is now here finished. Now it is if you have any question in the reaction injection molding or maybe any question in the injection molding process, you can ask me at any time, no problems. You can ask on maybe on my mobile also, you can ask me. Now let me tell you, we will going to start extrusion tomorrow onwards, friend. Right? We will take all how to manufacture a pipe, how to manufacture a wire, how to manufacture the cable, how to manufacture the blown film, the design of the screw, design of the barrel for the pipe. Everything we will cover here, friend. All parameters we are going to cover in the extrusion. So don't mix the extrusion lecture. And definitely, after listening my lecture, definitely you will be able to set up your own unit, right? Maybe pipe unit, blown film unit, maybe wire unit, cable unit, friend. Therefore, don't miss this lecture. Next lecture, coming lecture. I am going to start tomorrow extrusion. First lecture is very important. Try to attend that lecture tomorrow and thoroughly.
Sir, what about DCPD? You told us what you are going to cover DCPD.
DCPD, it is that we will definitely cover, because let me check up that with the systems, right? Okay.
Because that comes under reaction injection molding.
Yeah, yeah.
And DCPD now its technology is also good, kind of a good benefit.
Yeah. Nowadays people are using that DCPD also.
That's what very lightweight and very robust kind
yes,
of.
Yes. Lightweight, use article, dimension is stable. Without
that's what,
any...
sir, I want to understand if you can give some information about that. That will be very helpful, sir.
Yes, definitely. Yes, definitely.
Okay, sir.
Okay, we will meet tomorrow, friend, at the right time. Good night.
Thank you, sir. Good night.
Yeah.